All right, so let's say we start with just a generic line, and this line has a slope, let's say, of A over B. That means for every rise of A units, the run is B units. In order for two lines to be parallel, meaning they'll never intersect one another, okay, so in order for us to have a parallel line right here, for these two lines to never converge or start to get closer to one another, for every A units this line rises, what must it run to avoid ever hitting the black line, the original line? It's the same one, right? So if it rises and runs with the same slope, those are never going to intersect each other. So we know that the parallel line will also have a slope of A over B. So parallel lines have slopes that are equal. Okay, now contrast that to perpendicular lines. Okay, so if this green line here is perpendicular, the relationship that exists is they have slopes that are negative reciprocals of one another. And that just means their product is -1. So that's another way of kind of identifying that same relationship. So here, if the slope of this perpendicular line, so if these are perpendicular here, then its slope is going to be the negative reciprocal. That means you change the sign, becomes a negative, and you flip the fraction, becomes B over A. That means for every rise of -B, there's a run of positive A. So now we switch the rise and the run, and we change the sign in order to get that perpendicular.